morning we've got Adam Taylor here with us, which Andrew's already introduced as being the director of the DfMA program, and then our team that actually work with us on the DfMA guidelines. We have, over the past under a year, actually been working as an organisation to put together some design standards to enable us to give some certainty into the design of schools and the construction of schools to apply design for manufacturing assembly. If to enable design for manufacturing assembly to occur, you need to standardise your approach to how we're designing these schools, which is what we've done. And Ian Lomas from Woods Bagot will talk through in more detail about what these guidelines actually have in them. And this morning we'll talk about some of our lessons learned through that process. And Adam will also talk you through the school infrastructure prototype that we're going to be doing this first half of the year, and also give you a bit of an overview of what we think the future looks like for timber, particularly in DfMA. So within the guidelines, we have actually, as I said, talked about these design standards, and we took the approach that this can work for steel, concrete, volumetric modules or timber structures. It's not actually precluded to any one particular construction methodology. The importance for us was to ensure that we had schools designed so that they could be interchangeable between primary schools and high schools as enrolment waxes and wanes, which typically what happens over the 60-year lifespan of a school or longer. So the guidelines that are there to actually explain how you can apply any sort of structural systems, but it was really important that we made sure that from a perspective of enabling the timber industry and mass timber, that we had a structural grid 9 by 7.5, which suited all structural systems, but particularly it works well for timber as well. So in terms of working out whether it's primary and secondary beams, we've had floor-to-floor heights and all our analysis done by TTW, which did a really good job on this. And there's a lot of detail in this document actually shows how you apply this. The intention and purpose is that we have an open source of procurement to some extent, so that it's a benchmark for all designers, architects, engineers, and everyone in the industry to be able to understand how we're thinking about the ability to put schools together for students, and therefore everyone understands the knowledge that goes into it and can apply it quite readily. Some of the key benefits, and I think you're probably all aware of this with timber buildings, but particularly for education, some of the benefits around health for students are that you get a lower resting heart rate. There's been a lot of research to indicate that the connection with nature, biophilic design, actually helps in terms of ADHD and other sort of behavioural issues. We are not designed to be so removed from nature, and as all of you would know and are familiar with timber buildings, when you walk into them, you can smell the timber, you can feel it. Obviously it's there and it's obviously apparent in the classrooms or the buildings that you're in, and it has enormous health benefits for students in terms of concentration as well. So from that perspective, it's really important for us. For environmental sustainability, it speaks to itself, I think, in terms of lowering emissions and water and waste, and just improving the way we actually build and treat our environment from now into the future. And I think particularly with timber, there's an opportunity for us to build a sustainable industry in Australia around all types of buildings in different sectors being done from mass timber and a hybrid of using mass timber, which will only add to that plantation timber and that sustainable industry, which will only improve the quality of the buildings that we're doing and the environmental sustainability. DfMA particularly is important to us for the construction productivity that it actually generates. So when you start to move anything from 30% of your on-site practices into a manufactured controlled environment, you're going to see an uplift and increase in productivity. That productivity equates to being able to do more projects in a safe environment in probably a faster time frame. It doesn't actually equate to the loss of jobs. It simply means that your workers are being transferred from on-site to in a factory. When it's inclement weather, they can stay working in the manufactured environment. They can move between site conditions in a factory. But you will see that the same workforce is employed, but the productivity is increased. And as we know in the construction industry, our productivity has been less than 2% for nearly 100 years. So anything that we can do, particularly around DfMA and modern methods of construction, to increase productivity and profitability for our construction companies is a good thing. And that's certainly something that we're committed to at School Infrastructure. The other aspect to it is that the site safety, and we all know that there is a lot of challenges on site in terms of construction site safety. If we are able to do more of our manufacturing in a controlled environment and get our components ready to be transferred to site and have site assembly being more organised with less people on site, less interfaces and less trades, it equates to greater site safety. This also then moves into mental health, and we would be very much interested in seeing how we can move towards a 5-day construction work week as being the benchmark and a practice for all projects. And I think this has got proven benefits in terms of mental health for construction workers, those that work 6 days a week. It has an impact on all their families. If we can move to a 5-day construction work week and enable, DfMA will enable that to happen and still meet program milestones and so forth, then everybody benefits from it. And that's a really important aspect in terms of how we thought about putting these DfMA guidelines together and enabling the industry to move towards more sustainable practices and better mental health practices as well. Quality control obviously is much, much higher in a manufactured environment because of the QA checks and the systems that go into actually just controlling it. So anything that's done in a controlled environment is going to be much more of a higher quality than it's done on site. So true DfMA enables Australian-based advanced manufacturing, and this is what we see with the mass timber and timber buildings. It is true DfMA because a large portion of it has to be manufactured off-site and then assembled on-site. So of all the practices, it's probably, in my opinion, one of the most aligned with modern methods of construction in DfMA, and that's a good thing for the industry and for particularly for sustainable timber industry as well. The challenges that we found, particularly as we went through the putting the DfMA guidelines together, was there's a lack of technical expertise. And I think there are many that understand or propose to understand constructional detailing, particularly around structure, fire and waterproofing, and even maintenance operations, but there is actually a lack of expertise in the industry, and it's probably out there, but it's quite hard to find, and it's quite hard to find people who've had a lot of experience actually doing it, not that have actually just done an academic understanding of it. And then further than that, the supply chain understanding and comprehension is really critical, and that was found to be quite lacking when we went to the market to try and understand where we could get more understanding in that as well. And also then Australian approvals and regulations in terms of authorities of fire rated buildings and so forth as well. So it was so significant when we did our DfMA guidelines that we had to change our team 2/3 of the way through it to get the right advice, because we were finding that, and luckily I've had a fair bit of experience in this, as Andrew Dunn can verify, but you can be told by engineers that they've got experience in it, but until you've actually delivered a number of buildings, you don't truly understand what that means. And I think our industry will only grow in mass timber when we can actually understand where that expertise sits and how we access it more readily. And also the industry needs to invest in that expertise and trialling it on projects and buildings as well. The next challenge I see is being the construction industry changing their work practices to become more aligned with modern methods of construction and DfMA in particular, and then working with timber. Working with timber is a lot different than actually working with steel or concrete. There's a lot more care, I suppose, applied to it and needed on site when you do the on-site assembly. What we have seen though with projects like Meadowbank High School and Primary School, which Robert's Construction are delivering, is that they have actually worked with their subcontractors to move that construction industry mindset and had tremendous success with that, but that's been because of the leadership that they've shown. So the opportunity I see as being that we need to actually have a centralised and vetted mass timber technical expertise, a centre of excellence or something to that extent that any clients or developers can come to and understand where they're truly getting the right experience from people who have the deep technical knowledge and also the supply chain understanding. I'll pass on now to Adam Taylor to talk about the prototype of school infrastructure developing.
Yeah, thanks, Megan. As noted, Adam Taylor is my name. I'm Director of the DfMA program within school infrastructure. So Meg touched on some of the benefits there. So within school infrastructure in New South Wales, we've got a bit of a challenge ahead of us in providing infrastructure for a really very much an enrolment boom within public education. As Megan mentioned, we developed the DfMA guidelines and circulated them to industry late last year in December. So I'm sure there's an opportunity that we can share that link via Andrew following this session. Ian's going to talk through them from Woods Bagot in a little bit more detail later. But for us, the prototype really allows school infrastructure to bring that guideline documents to life. That guideline really starts to look at and open the door for, I guess, some more, efficient design and construction methodology, which obviously timber falls into that category. So Fern Bay for us, for those that don't know, it's located up in the Newcastle area of New South Wales in Australia. It's a school that has that rapid growth and they're experiencing that at the moment. What the timber prototype does is allows us to sort of look at different ways we can meet the infrastructure needs of that school that would traditionally be met by our demountable program. So it's really something that we're quite interested in as to how this could grow in the future and potentially be a wider program. So at the moment for us, we're sort of currently working up the design stage at the moment. We're sort of very close to releasing the tender for a head contractor. we're sort of running that project with our regional office up there in Hunter Central Coast, and sort of being very much supported by the DfMA team. So I guess for us, the prototype really is about sort of validating those quality and benefits that Meg touched on earlier, particularly sort of in that wellness area in students. It's particularly, the students are basically at the centre of everything we do within school, within the Department of Education. So not only that, obviously the cost and value of timber in a school infrastructure setting, the speed of manufacturing, ease and speed of on-site assembly. We also include logistics into that space. Obviously, the disassembly component for us, so that's it's vitally important as well. So as demand and demography changes in an area, we want to make sure that we've always got that, I guess, flexibility with our infrastructure that we can sort of disassemble and move to where the demand may be at the time. And also for us, just really important to understand and how we can improve, I guess, the relationships and contractor relationships between head contractor and those offsite manufacturers. So it's something that we're progressing through at the moment. As mentioned, we're sort of targeting sort of mid-year for completion, and there'll be a fair bit of comms from school infrastructure about this project that we can distribute to the industry following. So I'll hand back over to Meg just to run through the last of the slides before we wrap up.
Thanks, Adam. So really, I think overarchingly, there is, I think, a desire to see mass timber buildings become something which is of the norm, business as usual in Australia. I think there are so many benefits to it, and of course it plays into the initiative and strategic objectives around advanced manufacturing, particularly in Australia. We have some very, very talented architects, probably the most talented architects in the world, and I can say that from having worked globally. And I think that we need to support that a lot more. And we have an abundant supply of local mass timber product, which we should be using rather than importing it. So from our perspective, we see it as an opportunity for Australia to become truly a global leader in applying mass timber, be it in hybrid structures or as purest timber buildings in this, particularly New South Wales and in this state. And the whole mass timber production, design and manufacturing needs to be invested in and supported. And we think there's a real opportunity particularly ironically in this COVID environment to do that. But the industry needs to be able to access proven technical mass timber experience and expertise. And that's where I see the opportunity being, as to how we might actually enable that to happen more broadly for everyone to get access to that advice and that expertise. The DfMA guidelines that were put together with school infrastructure had a really good team. As I said, we had to swap that through halfway, 2/3 of the way through it, but we had Woods Bagot on architecture, TTW on structure, MBM doing all our cost planning, Holmes Fire, we had James O'Neill advising us on that, we had Mott McDonald advising us on sustainability, and we had Adam Strong bringing his mass timber manufacturing experience and more of a builder's perspective to it. It's always a team effort that brings these results, and without the expertise that we had in that team effort and the ability to bounce off each other and challenge one another, we would not have got to where we had with these guidelines. And hopefully they will set a new benchmark in how we actually think about designing and constructing and delivering our school buildings, and that's certainly the intent from school infrastructure. Thank you, Andrew. I'll hand that back over to you.
Good morning. This is Ian Lomas from Woods Bagot. Thank you, Megan and Adam, for the first part. And I think I want to reiterate Megan's discussion there about the team and the ability for us to challenge each other, and also to rethink the way that we look at and procure and design buildings. So what I'm planning to do is to use the DfMA guidelines as a basis for the talk today. It's all going to be out of sequence because it's an interactive PDF, but talk you through some of the principles, some of the challenges we've been looking at, and some of the opportunities. So when we look at the DfMA in the schools, we found it was very important to set out what our principles are so that we don't kind of forget and end up going down a rabbit hole. Now, these are schools, so pedagogy is always first and foremost, and that has to be the basis of everything we do. And by looking at what is the best teaching outcome now and in the future, we can also look at equity across the schools with consistency. Now, there's a resistance that says if you do consistent, it's all going to look the same, it's all going to be reductive and boring. I think we have to look at it another way, in the way that we can deliver the same level of quality of space and environment across the state of New South Wales. And within there, looking at how we can prioritize resilience and wellness. We have many different climatic conditions in New South Wales, and we also have rapidly changing climate with more extremes. How can we build something that remains relevant? As part of that, this kit of parts idea of all the different parts coming together, which allows an interchangeable module that works for all types of school, primary, high school, whether it's a lab, whether it's a fitness, whether it's a home base. And as Megan touched on, this is an opportunity through having this equity and this clarity of form to enable real investment in timber construction and other DfMA methods of construction, and so look at a whole of life thinking. Now, how do we proceed to do that? Just a minute, I'm having the problems now. Kit of parts or volumetric, we do not discriminate against different systems. And when we were looking at DfMA, one of the things which probably posed the biggest challenge, but also the biggest benefit, was how can we eliminate wet trades from site and make something that is truly modular and can be easily dismounted and reassembled without being destructive. Pedagogy changes all the time and will keep on changing, and it's never just one model, it's always changing. So how can we produce something that can evolve? And that means maybe looking differently at the way we design classrooms. I mean, even within a school, changing demographics, you might start by designing a primary school, it might become a high school, or it might become a specialist space. Too often we're building buildings that can't be updated, and then they're just left or they're demolished, which also speaks to the waste of materials, the time, and the money. And on sustainability, this is something working with Mott MacDonald that we were able to analyze critically: upfront carbon, health and well-being, operational carbon, user stage and end of life, all of these together. Very often, as we all know, projects are looked at the front end, or what you get at the beginning. But with schools, we're able to take a much longer view over the whole life and multi-generational qualities of the building and where the real benefits lie. And looking at different structural systems, it's very simplistic to go, timber is all good, and timber, we all love it. But there will be hybrids. There will be different settings where, due to the local workforce, due to the local settings, other materials or hybrids would come forward. But we've always got to be able to analyze this. On the upfront carbon, timber wins instantly, but we need to be able to grow a timber industry here rather than having to import it from the other side of the world. And climate resilience, we looked at every single climatic condition in New South Wales. We looked at daylight access, visual comfort, thermal comfort views, in interrogating all of the grids, all of the layouts, all of the facade zones to come up with an approach, a guideline of how this can be looked at. And then at the end of its life, how it can be disassembled and reassembled and reused, again using the same components. So what are those components? They are the core here, and I'm using timber as our core base structure here. Right in the middle, timber structure. Then we feed in there our partitions, our internals, which define the spaces, define the uses, and these can be taken out and moved so they do not prescribe the structure. Outside, we have facades maximizing daylight, maximizing views out, and then the facades, which will obviously vary according to orientation, location, like context. The roof, often overlooked, also a key element. Are we going to build up? Are we going to use it for energy generation? And then on the circulation, which comes on one side, collaboration areas, gardens, stairs, lifts, that all that plug in together. So I'm just going to take you quickly through the thinking here. Framework. What is that structural grid? What are the internal spacing? How do we brace? What's the facade? How do we plug in? And what happens on the roof? Now, our framework, we had a lot of modules here. So we almost see this like a 9-meter train track. Now, this can be one 9-meter or it could be two. The two allows larger classrooms. A single one allows it to be fitted in. Then we look at the facade, and we're really creating our chassis, our envelope that can then take all types of classrooms. We've got to look at what's the context, where's the orientation, where's the sun coming from, where's the wind. On all of these, too many school projects, or all projects to be honest, we kind of design in isolation and then they just kind of put around the site. This is trying to put forward strategies that look at the site first and create the best internal environment. always looking at access walkways to one side feeding into classrooms, which then allow the classrooms to be opened up and configured in multiple ways. Looking at a structural grid of 9 by 7.5, there are, of course, options that can be looked at this. We looked at all classroom types. So often we just look at a home base or just look at a GLS or just look at a lab. This looks at all of those uses in all their configurations and what would work best for them. So that along this kind of 9-meter rail, you can put home bases, you can put general learning spaces, labs, workshops. They can all feed along there and find their location in the school plan. And then within there, you insert your joinery items, your walls. All of the walls are joinery. All of the glazed screens are joinery. So everything can be made off-site. Nothing is permanent, and then it can be disassembled and moved to another school or in a different group. And these are some of the hubs and the different layouts that we're looking at. There's certain relationships of labs and classrooms and prep areas or different classroom hubs. This is just a snapshot, which is about 20 pages. Internal layouts. What can we do to actually remove finishes? This means we have to look at the floor not being a wet floor, a floor being a raised floor where we can bring services and change floor finishes. The joinery items, we can feed all of the surfaces into those joinery items to make them really working and drop them in to the site. And by looking at a regular module, which will run throughout all of schools across the state, it's then easy to upgrade and vary as you go through. And then you just order them down, slide them together. And if things need to change, you change the internals to the carcass in the same way you would a kitchen or wardrobe unit. When we were looking at structure, these are some of the criteria we're looking at. Barry will be talking in more detail, but we're looking at everything from the regulatory and the carbon to where it comes from. And of course, what it looks like. This is a slide we first produced, which is why we have the aesthetic right up front. I often think that the 5th sustainability pillar is, of course, beauty, because if it's beautiful, it's also going to stay longer. And then when we look at all of these systems, what do they mean to the space? What do they mean to the future flexibility? Because we've always got to think ahead 10, 20, 50 years as to how these buildings can be reused. Now, looking at the timber, we want to expose the timber. We want to show it off. It's a teaching tool. It's also a well-being tool, as Megan talked about, that whole sensory engagement with the timber. And how do we feed services through here so that it can be done orderly, it can be easily serviced, and it can be updated as we require? Now, here is a section through the structure. I don't know if you can see there's a primary beam, and then the secondary beams, and then the primary will create these secondary service risers across the top, which allow us to thread services through. And by having a floor zone, it allows us to run drainage, it allows us to deal with acoustics, different finishes on there, all within the same height. And that was something which really liberated us and allowed us to create DfMA buildings that were really DfMA. Looking at different facade construction methodologies, again, it doesn't all have to be the same. And this is looking to that corridor side where you could start to plug in different elements to create a school language that was bespoke to your school. And whether that's the walkways, the bridges, the lifts, the planting areas, all of these are in pre-described modules. We look at the bathrooms. How can we create bathrooms that are kind of anti-bullying, because there's always the way out? How can we have passive surveillance? This is born out of long and detailed discussions with teachers, with principals, with school groups, so that we can try and create the best possible arrangement. Here's one of the classroom groups here where we have home bases around the large practical activities areas, withdrawal spaces, bag storage. Everything is being put in there that feeds to get the best pedagogy possible. Facade options, again, this is where we can start to plug in. If you have your timber chassis, your main teaching spaces, that doesn't mean that the walkways have to be timber. There's a question raised here about the use in fire and maintenance and external. In this base case, we are looking at other materials for the external timber as well as timber. This shows steel. which can be used to form the classrooms. We can also create glazing so that we've got, say, a north-facing glazed corridor, which can be used during the winter months in our colder areas to be added in so you can ventilate. You've always got to look at ventilation, at prevailing winds, at the internal temperature. And these are the type of schools that we will be creating, schools which are based around the student and the pedagogy first, the internal environments, the long-term sustainability of the structures, as in relevance to pedagogy, in energy used, long-term viability, and also being able to easily upgrade across the state and within the building so that the buildings remain relevant and in place for many generations. I've just completed this part. I know I had a lot of slides to get through. If there's any questions, please ask, because I know this is necessarily just an overview. Thank you.
Thank you, Ian. This is Barry. Barry, can you please grab all the screen?
Thank you. Hi, my name is Barry Young, Director of TTW. I'll give you a quick overview today on probably more the end result, which is the timber building, but also the journey we went there to come up with a standardized design, which allowed us to come up with this kit of parts approach. Just bear with me. Okay. So the key design items were here. Number one, standardization of design. Now, to do that, it was really setting up the loading criteria, and I'll go through the loading criteria in a second, but really, we really had to make sure that we change the layout so all the 3 KPA areas were really put on the upper floors, because there had to be flexibility here that, you know, in 5 years' time that we could change the classrooms around total. The usages could change. The second criteria, yes, it had to be designed for manufacturing assembly. 3, local procurement, Australian procurement, New South Wales even better. Number 4, low maintenance. That was a key. You know, really, they have limited budgets on, you know, people maintaining buildings, inspecting buildings, all the things that timber could need. We had to design out. Future flexibility was the key. That future flexibility will be dictated in the early phases, so you may not have to design for it. But when we did that, we allowed for expansion both horizontally and vertically. And also there are some standard educational facilities and standards guidelines that have been around for a long time. They are going to be reviewed at some point in time there. I can go through those items in a second. So starting with loading, we discussed it, and I think it was agreed that the upper floors will be always a 3 KPA scenario. So all the heavier loads, gymnasiums, libraries, workshops, woodworking, metalwork, kitchens will go down onto the ground floors if they had to be down there. And therefore the ground floor itself, again, could be timber, but the base case was a slab, a concrete slab on ground. But that would be a case-by-case basis, especially depending on the lay of the land. And also on the right-hand side there, the EFSG guidelines, they have some minimum specifications, and some of those items there could be discussed further. Things like computer studies, computer areas, those really are classrooms nowadays. So I think when you come across these situations, you need to go back and get advice. But really, there's gone are the days of the old big servers and all those type of things. Future expansion requirements. So this will be assessed from day one when you start your individual project, whether you need to go upwards or horizontally. And for that reason, we've actually designed the structures so they, as Ian showed before, they can be plugged on horizontally, which will work with the bracing of the building, etc., all plugged on vertically. The horizontal plugins, as you can see the classrooms there, the modules, the 7.5 modules, 3 bays, but we negotiated shear walls that could stay there permanently, so you didn't have to modify the lateral stability of the building. And these layouts would have worked with the ground floor ones, which were the hardest ones, which could have been workshops, laboratories, etc., science labs, etc. Vertically, and again, case-by-case basis, if you do have to allow for vertical extensions, option 1 at the top there is you build really the first suspended floor, the next suspended floor that has to go on top. It's more about the capital input now, or whether you want to do it now or later. So option 1 is you put the floor on now and you put a lightweight roof on top of that. So there's less disturbance when you come to add on the floors. Obviously, waterproofing the building will just be the key when you do take off that temporary roof. The second option is, it really depends on the risk profile again, whether that second story is really or third story is going to be really required. But that option then is the walls and the foundation is designed for additional floors. And then you'd have to take off the roof, temporary prop the walls, and then add on that upper structure. Material choice. Now, obviously, we looked at all options, materials, steel, concrete, and timber. We looked at steel and concrete to make sure that the services strategy, the height strategies, the facade strategies, the fire strategies all worked, as well as timber. So all the grids worked on the 9 by 7.5 for the 3 different materials. And the floor-to-floor of 4.2 was really driven by the timber scheme. The timber options we looked at was steel and lightweight floors, steel and concrete floors, concrete, precast concrete with precast concrete beams and columns, precast concrete floors. Again, to test the heights, and then the volumetric. We didn't spend that much time on volumetric because there was individual suppliers already developing those in quite a lot of detail. With the timber framing systems, Ian showed you the final outcome, which indicated the 4.2 floor to floor. The system itself, when we did look at it, well, firstly, we did look at firstly material selection, the use of CLT versus glulam versus LVL. They're all interchangeable. We didn't have any preference to which material actually was used where. I think the key was even the same. Try to expose as much of it as possible. So when we looked at the options, we actually priced the options too. We looked at different grades of glulam beams, from your GL11s up to your GL18s. We were actually getting some very competitive prices on the GL18s compared to the GL13s. So to be on the conservative side, we went to the softer wood, the GL13, which is readily available grade, and we based our sizes on that. The CLT grade, we based it on the XLM XG, GP1 and GP2. There are other suppliers of CLT coming into Australia. They're really in their infancy, but they are becoming available. And then with the timber framing options studied, we looked at the traditional options of firstly the in plane, where the primaries and secondaries were in the same plane. Surface reticulation required notches in the primaries and secondaries or penetrations through the actual beams. The issues with that was future flexibility, and the approaches were that mechanical systems would vary between, whether it was a classroom, 4-cluster classroom versus a workshop versus a science lab. Science lab being probably one of the most demanding there for mechanical in any floor services. So it was also drainage from above that had to be considered. Where the bottom right hand corner there, the primary, we looked at primaries in the east and west with the secondaries on top. And then we ended up with the primaries going north-south and the secondaries sitting on top there. Now, the benefit of this system here, again, it was the layouts of the 4-cluster classroom. It worked really well with the current mechanical layouts. Again, if you were putting any wet areas upstairs, it allowed us to bring plumbing through and reticulate it back down to the risers. And this system here allowed for a 400 zone between the primary and the underside of the CLT, so ample room to get ducting and services through. Lateral stability. We worked very closely with Ian Lomas on the facade of the building and what is the lateral stability of the building. Now, with the lateral stability, we did investigate vertical bracing, but from a WH&S approach there, it was deemed that it wasn't safe for climbing, for children climbing the bracing, or even getting caught underneath the corners of the bracing there. So any bracing needs to be concealed. So we negotiated with Ian these on the elevation. So this is the front elevation and the rear elevation that faces the balconies, the corridors. So we've got at least 1.2 meters of zone of per bay that we can put bracing in. So equivalent, basically 2.4 widths you can get. This can be repeated on every bay, or if you don't need it, you know, it's really, you can minimize it. But also we had the challenges also to meet the actual shading requirements, etc. That, you know, we couldn't have too much glazing anyway. Fire. The approach with the structural systems, you know, steel and concrete. Concrete was obviously pretty much deemed to comply, required. Steel did need fire protection. That's for levels 2 and 3 story buildings. With the timber, the compliant DTS is really covered up with plasterboard. The timber is actually protected. So it is a performance-based solution to expose the timber. And this is for 2 and 3 story buildings. And sprinkled. So that's the approach that was taken here and signed off. And just finally, some of the keys again are just probably more about, you know, where do we use timber? You know, it's preferred that the timber is behind the cladding. They really have limited resources for maintenance. So really coming back and applying finishes to exposed timbers, they really don't have the resources for that. Which really then also, there's a lot of discussion on what do we do on the corridors, external corridors. If the corridors were going to be enclosed with glazing, because depending on the climate controls required in the schools, yeah, timber could be considered. But if they're going to be exposed to the elements, the base design we were looking at was steel and concrete. For the moisture management plans, also were in the actual guidelines, construction-wise, during construction, moisture management plans need to be put in place to make sure that timbers are protected. UV and sun protection and maintenance. We've also required that the timber have some type of light coating. That's like, it could be a lime wash, it could be something like that, that could be matched. So the issues we have with timbers, if you have to come back and sand them, graffiti, etc., sand them, it's very, very hard to color match them. So something there that'll allow you to do any minor maintenance and then still have the consistent appearance of timber. And there, the bottom left-hand corner, the termite management plan. Look, that's typical for all timbers. Again, schools would prefer to minimise the amount of inspections that have to be required. So again, that was the discussion we had about the ground floor. Is it timber? Is it concrete? It still can go either way. And that's pretty much the end of my presentation.
Thank you, Barry. We'll just now introduce Richard. Richard, please take the screen. You look at the screen sharing there, Barry. And Rich will give a talk about the costings. Thank you, Richard.
Okay, guys. Thanks for having me. I'm Richard Smith. I'm a quantity surveyor, sorry. To give you a bit of context as to why I'm here, I think my background has involved a lot of prefabrication and a lot of timber construction, both in England and here in Australia, although I've been here 20 odd years. So it just sort of illuminates the point I made later on that, that timber construction is not really new. Prefabrication is not really new. And we've been building in timber, of course, since the Neolithic period. So, I think to sort of suggest that we're dealing with anything other than basic construction is a bit of an urban myth, right? And I think because of my background, we MBM, sorry, we're engaged to provide the cost planning on the 5 modular schools that were part of sort of school infrastructure's journey through prefabrication that Richard Crooks and Hanson Juncken built. Those schools are John Springs, Alex Avenue, East Levington, Wagga and Catherine Fields. Have got more exotic names now, but those are the sort of 5 schools that I worked on. It's important to say that they were more closely aligned with volumetric modular type schools than the kit parts that some of the guys have mentioned so far. But nonetheless, they were absolute prefabrication, and these schools have been open now. Right? I think another important point here to make is that the costing of DfMA is absolutely not neuroscience, right? I mean, I think when MBM were first engaged as part of the DfMA team, and we started seeing the designs from Bagot, from TTW, and those guys, whilst there's not a lot of cost data out there, that there really isn't here in Australia, I think the first thing that we did was go back to first principles, in the sense that we disassembled each of these buildings, so in effect laid them all out on the floor and priced every piece of timber, every piece of glass, every door, every light fitting, and we sort of applied a very simplistic approach to costing, just to get an idea of what that raw cost should be before we sent it to market. And that second stage of that costing process that we've been through to arrive at the DfMA costings involved talking to market as well as the new suppliers, involved talking to builders, involved a lot of discussions with the design team to get to the cost that you've seen probably in the DfMA guidelines, which I'll talk about shortly. So is it cheaper? I know that's why you're all sat here listening to me, but just be patient. I'll talk about that in a second. I think it's important again to reiterate that this is really probably the easiest measurement job that you're ever going to go through as a quantity surveyor. I mean, you can see the sort of simplistic nature of this stuff, and even the framework here. And there's a reason it sort of looks like sort of children's toy set, is because it really is that simple, and it requires that level of imagination to cost and put this stuff together. So I think the urban myth around that we're dealing with something that's new and unusual and uncommon is largely inflated, and I don't really buy it. I think we've been putting men on the move for 70 years, so building a timber building to me doesn't seem like a giant leap for mankind really, or for the building industry, but it appears to be that way. As well, I think it's also important, whilst we are on a timber solutions webinar here, I think it's important to say that not all every element of the school is timber constructed. The concrete slabs are going to obviously built out concrete, some of the internal fit out, some of the surfaces, some of the roof. I mean, it's not necessarily a fully timber building, and I think that's important to reiterate, only because if there's just so there's no illusion that we are trying to push timber and purely timber as a solution for schools. That's not what we're talking about here at all, actually. I think it's important to say as well that there is a place for steel and concrete, and even the hybrid solutions, which I'm really interested in. I think we have to be sort of wary of pushing one solution. I think as an industry, especially, we need to become more flexible, more adaptive to different solutions. And I think as a quantity surveying industry as well, we need to be prepared to price different methodologies for school projects, and whatever works best should win out. There's no allegiance for timber, nor steel or concrete. Whatever works best on a particular site or a particular school should win out, right? In terms of pricing these DfMA schools, I mean, I think we sort of split it into a 3-stage process from pricing the stuff that's coming out of the factory and the supply of that, the installation of that on the freight, internal and external fit outs that might go on, might take place on site or not. That debate is still happening now. And then also some of the roof coverings, and the roof plumbing, which may or may not again take place on site or off site. I think we've allowed flexibility in our costings to cover each of those eventualities, right? But eventually we're going to arrive at a kit of parts total cost. In terms of what's in and what's out, you can see here that it's not any different from any typical QS cost plan. I mean, we're including everything essentially. Things like ESD, contamination, retaining walls, staging costs, land costs, locality costs. I mean, they're all specific to a particular project. So I think they'd be naturally removed from our costings. But that's just a typical clarification for you guys, just so you know what's in and what's out. So here's the most important slide of all mine. Is it cheaper, right? And I think what we're seeing is, or what we're putting our hand on our hand and saying is that it is. And I think there's some caveats around that low pricing, but ultimately, I think the journey that we're on, and bear in mind we're right at the start of it at the minute, would deliver a cheaper build, right? And we think it's about 10% cheaper than traditional. I'll talk more about what actually might happen in the upcoming tenders for DfMA, but generally speaking, we think, through all the methods of costing that we've undertaken, bear in mind that's the first principles costing, to the market feedback, to the engagement with new suppliers and fledgling school builders. We've aggregated all that, and we think that a 10% reduction in building cost is not just achievable, it should be an absolute given, right? Builders consultants have said look away now, only because there is, the part of the reason behind, the DfMA or the kit parts construction does produce a faster delivery. So, and the idea of having ministers being able to go on the news and guarantee, schools will be open day one, term one, and then be able to stay a year seems ludicrous, right? But it's I think this methodology does allow that more certain environment. And consultant fees, I've said, guys, I mean, don't anyone start throwing stones at me here. I think ultimately we're all going to have to learn to live with the fact that standardization and repetition will produce a lower consultant fee cost, but that's fine. I don't think there's any need to panic there. I mean, I think that's a natural course of events anyway. So I think, I've said observation and hope for the Luddites. I mean, that's deliberately inflammatory, only because, I think our industry has done a terrible job of evolving. And I think, part of this sort of initiative by schools is hopefully going to change some of the reputation around our industry, which hasn't evolved at all, right? I think the important thing to know, though, is that when we started out, this is very, very little benchmark data. I know Victoria's doing some things, albeit smaller schools. I know Queensland's done some, Europe, America's done some things, and all that is absolutely relevant, but there's very little here in New South Wales. So I think our costing journey, excuse me again, it's sort of been long, but it's been sort of predictably, I think, confirmed each stage by, we know how much the kit parts in isolation costs, we know how much the market is telling us, we know how much all that feedback aggregated, and the tenders we've had so far, including the modular schools, including the volumetric stuff, including the old demountables, it all does actually align. So I think that's been helpful for us to have those that commonality across the pricing. It's helped us, form a considered and I think confident opinion of where the cost should be. I think the good thing about the pandemic, which sort of took place while we were working in the DfMA team, was that it forced everyone to take a step back, sit down and think a little bit. And for the first time ever in my long career, is that we were getting meaningful contributions from everyone around the table. So instead of just a discussion that value manages and sort of downgrades a beautiful looking architectural building to a precast box, I think what we were seeing here was more practical, helpful contributions from everyone, and that was really good to see. And that was that was sort of an accidental think tank. It wasn't. I don't think that was not preordained. It was something that just came about. But I think this DfMA methodology has benefited from that. I mean, I've mentioned the Luddites earlier, but there is still obviously a resistance from certain sections of the industry to evolve or to adopt any new methodologies, and I think that's always going to be true, and that's fine. I think that's fascinating to me, of course. But I think what we were conscious of was that the more this DfMA team were together, the more information we were putting out to the market, the less resistance we were getting, and I think that ability to sort of change the minds of some more traditional type thinkers was very liberating and very sort of inspiring to a DfMA team, because we are trying to do something slightly different here. I accept that. I think the methodology itself, though, has got huge potential in terms of financial and sustainability as well, and I think that is important from a quantity surveyor's point of view, because as I see this thing is that we're at the start of journey here. And I think that, we'd expecting that, in 1-2 years that these costs will absolutely reduce. And I think all these other benefits that the other guys have sort of alluded to in terms of sustainability, wellness, all that stuff, I think that's absolutely going to come on board. I think the good thing I've also noticed while I was part of this team is that, you've got other big corporate clients, big real estate bodies talking to us about this methodology, and I, I mean, I could be wrong, of course, but I think, you can feel that there is a change in mindset around new ways of building, and I think that's been a long time coming, but I think I really do feel that something has finally taken hold here, and I do think that, this method of construction is going to become more wholesale, right? I did say, sustainability, wellness, DfMA, suddenly sort of buzzwords in the meetings I'm certainly involved in, and we also do a lot of jobs here in the MBM office. You might have 300 on the go at any one time. But I think what we've seen is that this sort of language is being sort of entered this construction lexicon, and that tells me that something bigger than just this schools infrastructure initiative is taking hold. And I think, as I sort of said earlier, that we're not ever going to build a basement car park out of timber. Well, Andrew Dunn tells me you might be able to, but I think there is always going to be a place for timber and steel, and I think it's important. It's really important actually to recognise that everyone has a place at the table. I just think timber's like an old friend we've got about, right? I just think we've got to reintroduce it back to the discussion table and not rule it out. There are, of course, some important caveats around the costs that we did, and I think I didn't want to bore you all here with running through the price of reinforcement and roof sheeting and all the rest of it on this sort of talk today, only because we only have 10 minutes. And I think I'm more than happy to share all the costings we did. I know that schools did produce a DfMA guidelines document that you can access, I believe. If anyone wants to talk to me afterwards, they can. But I've sort of kept the costs on a very broad scale. I'm telling you, it can be cheaper. Absolutely, it can. I think what the caveat around that cost is that we do need scale, and we do need a guaranteed pipeline, because without it, that momentum stalls. We are, after all, of course, asking an industry to build factories, buy machinery, skilled tradesmen, and I guess take on new ways of thinking for designers. All that stuff is none of it is going to happen unless we can sort of guarantee some work or an adoption en masse of this methodology. I think we need to do that. I also think we need to educate ourselves a little bit more, and perhaps as an industry invest in research and development, which lends itself to timber school buildings, of course. But I think that's really important, that we, as an industry, do spend a little bit more time learning about this stuff, because it really isn't quantum physics. This is really simple stuff we're taking on board here, but I do see sort of gaps in knowledge in our industry that I think needs to be fixed. I think it's also important to acknowledge that this really is the sort of the beginning of this new DfMA process. I think we should avoid catastrophic mistakes. I get that, and that's like I say, we're not putting men on the moon here. We're quite literally just building in a new material, or exploring new ways to design, or put up school buildings. Right. I think it's important to recognise there is a journey. There's lots of new relationships being formed, and there will inevitably be, I think, some interesting responses over the next 6 to 12 months in terms of tender pricing. I think we're going to have a wide range of costs, but I think because we have a solid basis for what the base cost should be. I mean, even when the builders add in their dark art of prelims and profit and float and risk and all that other stuff, I think we can, as an industry, come together a little bit better and help each other understand those costs and where the potential is for reduced cost, better time, and all the rest of those benefits that we spoke about earlier. Because I think it's very important to not shoot the messenger here, and I think the costs, good cost savings can be achieved. We just need to work together and understand where people might be misguided or might be adding too much risk or all the rest of it. So,
hey, Richard, can we now wrap up? So we pass over.
Yep. So I think my last slide here is anyway. So I mean, it is cheaper, it's faster, it's sustainable, it's safe, it's defects free. I think all those things are going to be commercialised eventually. Smarter guys than me will put $1 on those, add them to the bottom line, And I think they're benefits that are not in any of my costings yet, but they will be. So yeah, so it's all good news from my neck of the woods. So thanks for listening.
Thank you. All right, we actually gone past the time we want to spend on this, but what we'll do is I'll wrap up the webinar, and after the wrap up, then we'll ask some questions. So please hang around, panelists, and please, if anybody wants to ask any questions, write in the QA, and we'll address them after I just do kind of the completion of the webinar talk. But just want to remind you that the questions they'll be available certificates sent to you, and also the webinar will be available later on. This is the series 4th in the series of 5 talks, and so we're now done 4 of them. Our next one is going to be on timber arch and dome buildings, which will be presented by Haring Timber and Sergio and Chris Haring this time next week. And that's absolutely fantastic stuff, what the Haring group have been doing when it comes to timber buildings and particularly dome buildings. And next Tuesday talk is on the 2nd of March, which is best practice for energy efficiency and healthy buildings by Mike Dewsbury. So don't forget about a certificate and CPD questions will be sent to you. And also to help you in the part of the CPD question sent to you, there's a survey, so please take the time to fill it out. So at this point in time, I'd like to say that for people who want to leave, please leave. But anybody who wants to hang around, we'll address their questions. And panel, you can hang around. We'll address the questions for about 5 minutes, and then we'll come to an end. Okay, I'm just trying to. So there's a question probably to Adam and Megan. And Megan, is that this use of timber, has there been a change of thinking in schools infrastructure to allow timber, and is it for all buildings? Was one question that was sent through.
I think Adam can probably add to this too, but I think I did write a response to that saying that it's certainly for the design center.
Richard, could you put yourself on the mute there? You just a bit of background noise.
Yeah, so it can be steel, concrete, hybrid, mass timber in terms of how we've done design standardization, but the prototype, which I think Adam should probably respond to.
Yeah, I'll just chip in there. So I think certainly the question around, we've been working very closely with the EFSG and also our asset management unit, which Barry alluded to, just about that maintenance and ongoing sort of cycle life cycle cost of building. So yeah, there's certainly probably been a maturity in school infrastructure around timber, and I think that's probably the key space. So we are very much working very in line with our EFSG team and our DfMA guidelines and how they interact. At the moment, it's very much the intent that the EFSG will be sort of updated to resolve probably a lot of those issues you faced 5 years ago or so.
Okay, thank you. Question here from Blake and more just to Ian. What energy efficiency measures have been implemented? I'm thinking of air tightness, insulation, thermal bridging, moisture management.
Hi. So I don't know if you can see me. Right. What we've been working closely with both schools' own sustainability team and also with Mark McDonald and with obviously Barry and TTW. All of these, all putting forward, and that will be in the guidelines. We set out all the criteria. What we realized the most important thing is to measure as we build, because there's a lot we can put out in theory, and then we want to see how the buildings are being used. For example, we are looking at the building's design so that air conditioning or treatment is not required as the base, but we're actually building the buildings to take full advantage of natural and mixed mode ventilation wherever possible. Now, you can talk a lot about this, but you want to see how it works in operation. And so this is a continually kind of ongoing, what are we benchmarking against, what are we delivering, and how is it behaving in its whole life cycle. So this is a continual process which we want to kind of learn from and evolve, and all of the different benchmarks are all set out in the guidelines, which I believe are available when they issued at the end of last year, rather than me go through every single one.
Sure. And just another question for Anonymous, just for the embodied carbon benchmarks per square metre, you know, is there any guidance on, the question is, 0 to 10%, 20% reduction targets, etc. like that?
Again, what we've looked at is a whole series of different hybrid systems. There is going towards about 50% when we can get locally sourced timber, because there is one thing of saying, oh, we're going to use timber and it has to come from Canada or Norway. We're looking at local. We're looking also with Barry and his team about how does locally produced CLT behave. It has different structural, different behavioral properties to others. So we've been working in on that, and there's a whole series of tables and studies which go through all of that. So that again is in the guidelines, which we can go through more detail and bring the relevant people to that discussion.
Thank you. And a question for you, Richard, and it's from Jean. Have the preliminaries been factored in as a cost savings, and how is this adjusted according to height scale? And there's a statement beforehand talking about 3 to 4 story buildings.
Yeah, I mean, I think, you know, the prelims are actually part of the reason why the methodology is cheaper in the first place, right? I mean, it's, you know, it's less people on site, less supervision, and less time on site, right? So obviously those costs play out in prelims. You know, you still got a site to manage, you still got landscaping to do, you still got an assembly to supervise, all the rest of it. But ultimately, the big saving is in preliminaries, right? There's no question of it. And in terms of, you know, the 2-story, 3-story, 3-story, you got to. I mean, most of our buildings here were based on costings are based on 2-story typical schools. You've got to, you know, you've got to cost every project on its own circumstances, of course, but yeah, I mean the savings in prelims might reduce if suddenly we're building, you know, 7-story schools, but yeah, there's an exercise you can do, but there's no hard and fast answers. But ultimately, you know, the closer you get to that 2-story school, the bigger the savings in prelims.
Okay, thanks, Richard. No, I'm not seeing any other questions. There's a couple of thank yous from there, and no DS presentation from our QS, which is great, and thank you from that. But at that point in time, I'd like to now wrap up this webinar. Thank you, speakers, Megan, Adam, Barry, and Richard. A brilliant presentation. I wish we had more time, because I know all of you could have said more if we had more time. But we thank you for this, and we thank for the people to hang around for the time to past the hour. And we'd like to see you at our next webinar, which will be in 7 days' time. So thank you. So we'll close up now. All right, speakers, thank you very much. We're still broadcasting live, so I won't have a conversation with you. So I'll now close down the webinar, and thank you for a brilliant talk. As usual, it was tight to get all our comments in and our presentation, but well done. And we had close to 300 people attending, so it was a good attendance. So thank you.